Okay, so today we're going to learn about writing linear equations in different examples. So for the first one, what if 2 points are given? How do we write our linear equation? Well, for this one, we're going to use the point-slope form. And the point-slope form equation is given by y minus y1 equals m times x minus x1, and these are your 2 points. So you can just assign any of those two to become your point. Let's name this as our point 1, and let's name this as our point 2. And because this is our point 1, I'm going to call this as my x1, y1. This would be my x2, y2. The x1, y1, x2, y2, we need it for our m. Our m is our slope. M is y2 minus y1 all over x2 minus x1, which is actually the same as delta y, or the change in y over the change in x. So delta is a Greek letter that represents change in math. All right, so let us begin. First of all, I need my m. So I'm going to go ahead and substitute this. Looking for m, I will have 4 minus negative 2 all over my x2 is 2. Minus is fixed. Those are your operation signs. And this is minus 2. So this becomes 4 plus 2 all over 2 plus 2, which is 6 out of 4. Reduce this by 2. You're going to have 3 out of 2. And this is your slope. That's your m. So let's go ahead and do this. I'm just going to use my x1, y1 for this one. But you can actually use both. It's the same thing. So y is fixed minus, that is a negative 2. So I'm just going to put a parenthesis, equals m. That's your m. X is fixed. Minus is fixed again. And then that's negative 2 for your x of 1. Double parentheses. So y plus 2 equals 3 over 2. X plus 2. That is already considered an equation. But if we want to isolate the y and make it just y equals, then it would look like this. I would like to go ahead and extend this lesson into changing this to slope-intercept form. Which is y equals mx plus b. If that is the case, then we will have to fix this a little bit. It will have to be distributed because by the order of operations, you do the multiplication first before you subtract. So this would now look like 3 out of 2x. And that would be plus 3 out of 2 times a2. Because you're going to multiply, we will simplify that later, and then minus 2 right here. This will now be y equals 3 out of 2x. This has a denominator of 1, so this will cancel out. So that's a positive 3 minus 2. Your final equation for slope-intercept form is going to look like 3 out of 2 plus, 3 out of 2x plus a1, which means that your m or your slope is 3 out of 2, which we got a while ago, and your y-intercept is a positive 1. Example 2 is 0.1, 2, 3, so that's x1, y1. This is 0.2, so that's x2, y2. And again, point slope form has a formula of y minus y1 equals m times x minus x sub 1. Where this is, these are the coordinates of your point. Any of those two will do. This is fixed, and that's your slope. So let's do our slope first. So our m is y2 minus y1 all over x2 minus x1. We will just follow all these notations. So my y2 is 1, minus right here is fixed. My y1 is 3. My x2 is 3. My x1 is 2, so that's a minus x1 is 2. So that's a negative 2 all over 1. So this is going to be a negative 2 out of positive 1, which means that this is your rise and this is your run. So we will have our m to be negative 2. This one is important for graphing. We will do that in a little bit, but this is for our equation. So with that, I'm going to substitute in the point slope form. So y minus, I'll just use this. So 3 equals negative 2 for m, parentheses, x minus 2. So y minus 3. Okay, or what we can do is, this is already an acceptable equation, but let's work this out further. X minus 2. This goes to the other side, so that is plus 3, but outside the parentheses. That's your equation. However, if you want to extend this and put it in slope-intercept form, which is y equals mx plus b, then I will have to distribute the negative 2 to both. So it's going to look like this times this, negative 2x. This times this is positive 4. Then plus 3. Your final equation is negative 2x plus 7, which means that your slope is negative 2 and your y-intercept is 7. Okay, for example number 3, I have a 0.5, negative 4, and the slope is given as 3. Since this is given, I can just go straight to my equation that is y minus y1 equals m times x minus x1, where this is my x1 and this is my y1. My slope is 3, so that is m. So I can just easily substitute. Y is fixed, minus is fixed, y1 is negative 4, equals m is 3, x is fixed, minus is fixed, and then my x1 is 5. So let me fix this. This becomes y plus 4 equals 3 x minus 5. Y equals 3 x minus 5 minus 4. Make sure it's outside the parentheses. And that is already your equation. Now again, if you want to go ahead and extend this and make this look like a slope-intercept form, then you will have to use y equals mx plus b as your equation, which we can easily do. You need to distribute the 3 to both the x and the negative 5, making it become y equals 3x minus 15 minus 4. Then it's y equals 3x minus 19. Now what does that mean is your m is 3, which again we already discussed, and your y-intercept is negative 19. So what happens if you have example 4 where there is just a graph and you want the equation? Well, what you can do is if there are points that are identified, you can get the coordinates. So this is negative 1, 3. And this is this is positive 1, comma, negative 1. And you're going to use the same formula. So y minus y1 equals m times x minus x1. So I'm going to call this my P1.1, which is my x1, y1. This is my P2, which is my x2, y2. I'm going to see if I can do my rise over run here. 1, 2, 3, 4. My rise is 4. That's positive 4 because I went from here up. And my run is negative 2 because I went to the left. So my slope I know is delta y over delta x, which is the change in y over the change in x, which means I just do my rise over run. So I do my rise over run. My rise is positive 4 and my run is negative 2. Therefore, my slope is a negative 2. And then I'm going to substitute. So I will have y minus 3, my y1, equals negative 2, parentheses x minus x1 is negative 1. And that is it. I'm going to have y minus 3 equals negative 2, x plus 1. I'm going to, that's already an equation that is acceptable. So you will have another way, which is negative 2, x plus 1 plus 3. Again, outside the parentheses, that is already an equation. But if you want to extend it to slope intercept form, then you will have to use y equals mx plus b. And you'll have to distribute the negative 2 to both the x and the positive 1. Therefore, you will have y equals negative 2x minus 2 plus 3. And you will have y equals negative 2x plus 1, where your m is negative 2 and your y-intercept is positive 1. My last example is really not an example. It's just kind of gonna challenge you to extend your own learning. So if you're given a table where you have x and y, how are you going to get the equation of this line? So my suggestion is to take these points as your x1, y1, x2, y2, any of those will do. And then do the same process of substituting in the formula. Y minus y1 equals m times x minus x1, where y and x are fixed, but y1 and x1 are any of these 3 points, because that's 1 point, another point, that's another point, and your m is your slope, which is in the formula you can get using the formula y2 minus y1 all over x2 minus x1. So good luck on your learning on this one.